All right, section 4. Okay, let's start off with some more definitions. Lots to understand here. So first off, my matrix A is an M by N matrix. So that means there's M rows and N columns. And so that means I have columns A1 through AN, so those are my N different column vectors. And then this X, AX is in Rn also, right? This is the matrix A and the vector X. All right, so the product AX is really the linear combinations of the columns of A using X as the entries of X as the weights. So AX, we take this column vector, we multiply it times that constant. We take this column vector and multiply it times the next constant. And then this last column vector times these constants. So these x's that are not in bold are constants, right? So AX only works or is only defined when the number of columns of A equals the number of entries in A, right? So each column vector in A has to have a different number to multiply by it. So here's an example. So I have 2 columns and I have 2 entries here. So this first column gets multiplied times the number 4. And then this second column gets multiplied times the number 7. And then you know how we multiply constants and vectors. We multiply the constant times each entry of the vector, the 7 times each entry of the vector. Then I add their entries together to get this. So this AX equal B is called the matrix equation because I've got this A as a matrix. So if I have A, an M by N matrix, then there's N column vectors, right? Because there's M by N, there has to be N columns. And if it's X is equal to B, so this B is in Rm. So that means there's M entries in there, right? So AX equal B which is the matrix equation, has the same solution set as this vector equation. So you should know the difference between the matrix equation and the vector equation. And they have the same solution set as this augmented matrix. So it is true that AX equal B has a solution if and only if B is a linear combination of the columns of A. All right, good one to memorize. All right, so if I have this set of N vectors, right? And each of these vectors in Rm, that means each of them have M entries. And if I know that B is in Rm, it takes a linear combination of vectors in Rm to get to another vector in Rm. So if I have 2 vectors in R3, that's the only way I can get to another vector in R3. Here I have vectors that are in R2, and I add them together. That's the only way I can get to a vector in R2. So lots of details here, nothing profound. All right, so let's start with this. Here I have, this is the matrix equation. So let's rewrite this as the vector equation. So the vector equation will be this number x1 times the first column vector, then this number x2 times the second column vector, and then the number x3 times the last column vector, and that all equals this. All right, so this is the vector equation. Rewrite this as the matrix equation. So 591, whoops, sorry. That's going to be the augmented. 591, negative 628, 842, right? And then times x, and I'm just going to rewrite x as x1, x2, x3 equal 4, negative 1, and 6. So that's the matrix equation. Okay, so first, this one here, I'm being asked to write it as the vector equation. And then as the matrix equation. So the vector equation and the matrix equation. So the vector equation would be x1 times 3, 0, right? Because there's no x1 term here. x2 times 1, 1. x3 times 5, 4 equaling 9, 0. Okay. Then if I wanted to write it as a matrix equation, that would be 3, 1, negative 5, 0, 1, 4, x, right? I could write x like that, or I could write it as x1, x2 is equal to 9, 0. All right, now let's go solve the system. So that means I'm going to make the augmented system, or augmented matrix out of this. So 3, 1, negative 5, 9, 0, 1, 4, 0. All right. So let's first, let's see. I'm going to leave the 3 here for a second, and I know this will be a pivot and this will be a pivot. So I'm going to work on getting a 0 here first before I make fractions. So I'm going to take negative 1 times row 2 and add it to row 1. So this row will stay the same, and then I'll get negative 9, 9. Okay. So now I'm going to multiply 1/3 times row 1. All right. So now I'm ready to get a solution, get what this means. Remember, this is an augmented matrix, right? So what does this row 1 mean? So this row right here is saying x1 minus 3x3 equals 3. Right? Now what is the second row saying? That row is saying x2 plus 4x3 equals 0. All right, you always solve for your basic variables, and your basic variables are your 2 pivots. So these are my 2 pivots, so I solve for those 2. So that gives me x1 is equal to 3 plus 3x3. x2 is equal to negative 4x3. And then what do I know about x3? x3 must be a free variable. And we'll talk more about how to rewrite this, but I want to make sure we're getting comfortable with this step right here.